Hello dear students, welcome to YouTube channel of Unique World Education. It's me Fazlur Rahman, chemistry faculty of Unique World Education. Hope all of you are doing great. Today we'll continue with sample question paper discussion of grade 10 science chemistry part. Actually we did one video for that in which we discussed about the MCQ part, first section of that chemistry questions. I hope all of you watched that video and all the questions were clear, exactly clear. So today we are going to continue with section B and section C questions of chemistry part from the question paper, sample question paper, which is released in the official website of CBSE for 2024-25 session. Okay, we can start directly. We can move with the questions. So question number 21 of section B. It's regarding chemical equations. Chemical equations, I hope all of you are clear with all concepts of all chapters. Okay. First one, identify the type of each of the following reactions, stating the reason for your answers. So two reactions are given here. You have to identify the type of reaction and you have to give the reason. Okay. First one, Fe2O3 plus 2Al gives Al2O3 plus 2Fe plus heat. Okay. Plus heat. If you see plus heat after the arrow mark, that means right hand side of the equation, you can confirm that reaction is which type? Exothermic reaction. Exothermic. Exothermic. Exothermic means what? This type of reactions which release heat energy outside. That's why that plus heat is given after the arrow mark. Okay. If that plus heat is there before the arrow mark, you can consider, you can confirm that reaction which is an endothermic reaction. Okay. So first reaction is an exothermic reaction. Exothermic reaction which release heat outside. Okay. And apart from that, you can see Fe2O3 plus 2Al gives Al2O3 plus 2Fe. Okay, actually here two metals are involved in this reaction. One is iron and one is aluminium. Okay, actually in this reaction you can see Fe2O3 become Al2O3. What's happening here? Aluminium displaces iron from iron oxide. Okay, so it's a displacement reaction as well. Displacement reaction. Exactly, it is single displacement reaction. Single displacement reaction. Because a highly reactive metal aluminium displaces a lower reactive metal iron from its oxide. Okay, so first reaction is an example of single displacement reaction. Reason, highly reactive metal aluminium displaces lower reactive metal iron. Okay, all of you know the reactivity series. Okay, iron is coming below hydrogen. It is a very lower reactivity metal. Okay, sorry, not below hydrogen. Iron is less reactive than aluminium. If you check the reactivity series, aluminium will be more reactive than iron. Okay, so that leads to displacement reaction, single displacement reaction. Okay, so that's about the first one, and it's an exothermic reaction also. Exothermic reaction. Coming to the second one, coming to the second equation, that is PbNO3 twice. What is PbNO3 twice? That is lead nitrate plus Ki, potassium iodide, gives PbI2, lead iodide plus potassium nitrate. This is you can see the exchange of ions between the reactants and products. Ions are getting exchanged. So what are the ions here? First, in the first case, there are Pb2 plus ions and NO3 minus ions. Okay, lead ion and nitrate ion, and in second one K plus ion and I minus ion. Clear? You can see when it comes to product side, these ions are getting exchanged. Okay, actually Pb2 plus ion was with nitrate ion in the first case, but when it comes to product, it is like PbI2. PbI2 means that is Pb2 plus ion and I minus ion. So now Pb2 plus ion is combining with I minus, not with NO3 minus. So that indicates exchange of ions. Okay, and this is KNO3, K plus and NO3 minus. So NO3 minus ion is now with potassium ion. So there is an inter-exchange of ions between reactants. Okay, between molecules. That type of displacement is called double displacement reaction. Okay, double displacement reaction, double displacement. I hope the reason is clear, because there is inter-exchange of ions between the reacting molecules, okay, and products. And apart from this, you can say, what do you mean by this particular down arrow? That means that is a precipitate. That is a precipitate. PbI2 will be a solid which will precipitate, which will not dissolve. Okay, so for that reason you can say that reaction is a precipitation reaction as well. Precipitation. Okay, precipitation. So I hope this is clear. So first reaction is an example of single displacement reaction and exothermic reaction, and second reaction is an example of double displacement reaction and precipitation reaction. Clear? Okay, good. Moving to the second question. It's a long question. We can read the question carefully first. Anirudh took two metal oxides. Okay, Anirudh took two metal oxides. Aluminium oxide and magnesium oxide. Aluminium oxide Al2O3 and magnesium oxide MgO. Yeah, as shown in the picture given below, but he forgot to label them. Okay, how will you guide or help Anirudh to identify the oxides and label them? Okay, so two oxides pictures are given here, aluminium oxide and magnesium oxide, but the student don't know which is that exactly. He forgot to label. So how you people will guide Anirudh to label these two oxides? So you have to think about the property of these two oxides, then only you can help him to label. So we know what is the nature of metal oxides. What is the nature of metal oxides and non-metal oxides? Metal oxides are basic in nature or alkaline in nature. Metal oxides are alkaline in nature, and non-metal oxides are acidic in nature. So magnesium oxide, all of you know magnesium is a metal. So magnesium oxide is a metal oxide. Magnesium oxide is a metal oxide. Metal oxides are basic. A solution of metal oxide, an aqueous solution of magnesium oxide, aqueous solution of magnesium oxide will be alkaline in nature. Okay, alkaline in nature. So you know about color change produced by litmus papers. Okay, so if a solution is alkaline in nature, you can test the alkalinity of that solution by using litmus paper. Okay, so what is the color change of alkaline or basic solutions? So it will turn red litmus to blue in color. Okay, so red litmus to blue color. Okay, So that is the observation, or in by checking this way Anirudh or that student can label. Okay, so what he have to do, so he can mix this solutions, mix this particular powders, magnesium oxide and this aluminum oxide. He don't know which is magnesium oxide and which is aluminum oxide. So what he have to do means, so mix with water. Okay, this two powder mix with water, so and check with a litmus paper. So out of this two solutions, two aqueous solutions of this oxides, metal oxides, which is turning a red litmus to blue color, he can confirm that will be magnesium oxide, because magnesium oxide, an aqueous solution of magnesium oxide, metal oxide, will be basic or alkaline in nature, which can turn red litmus to blue color. Okay, yes, but coming to aluminum oxide, what is the nature of aluminum oxide? Aluminum oxide, all of you know, aluminum oxide is amphoteric. It's a metal oxide, but it is amphoteric in nature. It is amphoteric in nature. I hope you remember the word amphoteric. Okay, it's very important. Amphoteric means which can react with both acids and bases. Okay, it can react with both acids and bases. So there will not be any particular color change using litmus paper. Okay, so when you put red litmus to this solution, okay, first you have to add some water to this powders, then you will get an aqueous solution of these two oxides. So if red litmus is turning blue, that you can confirm that is magnesium oxide, and the other one will be aluminum oxide. Okay, aluminum oxide will not turn or will not produce any color change with any of the litmus papers. Okay, because that is amphoteric in nature. Can you please tell me which is the other example of amphoteric oxide that we have studied apart from aluminum oxide? What is that? That is zinc oxide. So both are very important. Zinc oxide and aluminum oxide are amphoteric in nature. Okay, good. And coming to the next one, yeah, one more question is there with this one. Yes. In an activity, Aishu was given two substances, copper sulfide, Cu2S and copper oxide, Cu2O, copper oxide and copper sulfide. To obtain copper from these compounds, she was able to extract copper successfully. Illustrate with the help of chemical equations how Aishu might have completed the activity. So we have studied in the chapter metals and non-metals. There is a separate portion for extraction of metals. Okay, extraction of metals, and this is exactly coming under extraction of low reactivity series, lower reactivity metals. Okay, so I hope all of you know extraction of metals coming in lower reactivity area, that can be done by simply heating in air. Okay, by roasting only. Clear? So copper sulfide and copper oxide are examples of ores of copper. Okay, so important ores of copper which are present in sulfide form and oxide form, so which can be just simply heated in air. Okay, so you have to write the equations of that process, how you can extract copper from copper sulfide and copper oxide. That's it. Okay, so I'll write the equations here. I hope all of you know that. Okay, so first one, copper sulfide. So copper sulfide, Cu2S, you have to heat in presence of air. Copper sulfide plus O2 gives, you will get what? Oxide, copper oxide, Cu2O plus SO2. Okay, heating. Okay, you can balance the equation, so that will be like 2 Cu2S plus 3 O2 gives 2 Cu2O plus 2 SO2. So this is the first equation. Okay, and second equation, from this Cu2O, this Cu2O again will react with one more molecule of Cu2S. So you can write Cu2O plus Cu2S gives, again heating, Cu plus SO2. Cu plus SO2. Okay, so now pure copper is extracted, pure copper is separated. Okay, so these are the two equations you have to mention in this particular answer. Okay, so using copper sulfide and copper oxide, we can extract pure copper. Clear? Yeah. Then coming to the next question, yes, in the a series of reactions is given. Listen, in the given series of reactions, name the compounds X and Z. Okay, and which type of reactions is X to Z? Okay, yeah. So first one, NaCl plus H2O plus CO2 plus NH3. Okay, NaCl plus H2O plus CO2 plus NH3 gives X plus Y. That X plus Y, that X on heating gives you Z plus H2O plus CO2, and that Z plus 10H2O will give you a compound Q. Okay, NaCl plus H2O plus CO2 plus NH3. What is this called exactly? What is this called? Actually, NaCl plus H2O. NaCl plus H2O, that is brine solution, brine. NaCl plus H2O is actually brine solution. Okay. NaCl plus H2O plus ammonia. What is that? Ammoniacal brine solution. Ammoniacal brine solution. So this reaction is exactly passing carbon dioxide gas through ammoniacal brine solution. So you will get two compounds X and Y. You remember which is this reaction? You will get two compounds. One is NaHCO3 plus Y is ammonium chloride, NH4Cl, ammonium chloride. Okay, so X is NaHCO3. What is NaHCO3? NaHCO3 is sodium hydrogen carbonate or sodium bicarbonate, which is called baking soda. Okay, and this is ammonium chloride. And look, the next reaction is this NaHCO3 on heating, NaHCO3 on heating, you will get one compound Z, that is, which is that, can you please tell me that? NaHCO3 on heating, decomposition, okay, thermal decomposition of sodium bicarbonate gives you what? Na2CO3, Na2CO3 plus H2O plus CO2. Okay, so Z is Na2CO3. What is Na2CO3? Sodium carbonate. Okay, not sodium bicarbonate, sodium carbonate. And if you add 10 molecules of H2O, if you add 10 molecules of H2O to Na2CO3, you will get another compound, that is what? Na2CO3 10H2O. Na2CO3 10H2O. What is this? This is washing soda. Washing soda or sodium carbonate decahydrate. Okay, sodium carbonate decahydrate, sodium carbonate decahydrate. Clear? I hope this is clear. So I am repeating again, excess sodium hydrogen carbonate, sodium hydrogen carbonate or sodium bicarbonate or baking soda. Okay, baking soda. And why is sodium carbonate? Na2CO3 sodium carbonate, sodium carbonate, and Q is, sorry, not Y, Z is sodium carbonate and Q is washing soda or sodium carbonate decahydrate. Okay, and which type of reaction is X to Z? X to Z. X to Z is which type of reaction? That means NaHCO3 converting into Na2CO3 plus H2O plus CO2 by absorbing heat. What is that reaction? That is thermal decomposition reaction. Okay, thermal decomposition of sodium hydrogen carbonate, or you can say that is an endothermic reaction also. Endothermic. Why? Because that is absorbing heat. Absorbing heat. Okay. Yes, I think that's clear. So this type of questions are very important. Okay, so you have to be very perfect with each and every reactions which is given in your textbook. Okay. Yes. So I think it's almost time. So we can discuss about the remaining questions. So this question and section D and E questions also will be there, that we'll do in next class. Okay, I hope all of you are clear. If you have any doubts, you can come in comment box. Okay, students, bye, take care all.